Okay, so let's see now. Let me stop this. Okay, rotorcraft operations and aerodynamics. So we have seen the fixed wing. So fixed wing is like similar to your aeroplane, or fixed wing is similar to your aircraft, normal civilian airplanes, whatever they fly. Same operations or same way it will fly. Okay, but it is just a miniature of the big planes or big aircrafts kind of thing. Okay, I could say it could be a smaller version of the actual airplanes. Okay, you can see, right? Huh? So rotorcraft operations and aerodynamics. So what is the basic drone overview? Types of motor, rotor, multi-rotor drones, quadcopter anatomy and terminology, internal, inner electronics of the drones. What electronics does it uses? And we'll see some applications of this type of drones. Okay. So what is drone? Drone is a aerial or a ground or underwater vehicle without a human pilot on board. So either it could be a drone which is flying in the air, it could be even on a ground, it could be moving on its own, or it could be like a mini submarine also, like without
Okay.
without a
Underwater drones.
underwater drones kind of thing. So it is also known as unmanned aerial vehicle. We talk about UAS. Here we are talking about UAV, or also remotely piloted vehicle. Some people call as RPV. Okay, the entire system, unmanned aircraft system. I told you, the entire system, not only the drone, but could be your remote control, your ground control station. That entire thing is called system. Okay, whenever the word system comes, means entire system is known as unmanned aircraft system or remotely piloted aircraft system. So that is what we call as complete drone and its subsequent day. So RPAS, if you see, RPAS is nothing but RPA plus GCS or ground control station, or maybe even your remote control also. So whatever you are on the ground, from where you are communicating or controlling your RPA, and that entire RPA plus GCS is called RPAS.
Okay.
Clear on this? Lot of
Yes.
time people make confusion and with understanding with RPAS and RPA and GCS,
No, no, no. I'm clear with that.
especially the RPAS and RPA. Okay, when there is S comes, means we are talking about in totality the complete system.
Okay.
Okay, so now let's see, understand how does a drone flies, or how does drone works. So it may be remotely controlled by human operator. Okay, so as a human operator, you are using a remote control and you are flying the drone. Okay, so
Yeah.
the remote control, the signals are, or the controls are being given, fed to the drone, and then accordingly the drone will fly as per your recommendation.
Yeah.
Or using or using the GCS, you can fly autonomously with the help of onboard computer. So you will feed the data over here, you will define the mission plan and everything, and your drone will perform the functions based on the flight plan. So autonomously it will fly.
Okay.
So what are the different types of multi-rotor drones? So whenever you have a rotorcraft with more than two rotors, it is called as a multi-rotor drones. Okay.
Yeah.
So further they are classified based on number of rotors. So two rotors is two rotors, birotor or something we call it. Three rotors, it is a tricopter. But having a tricopter, it's very difficult because in three segments you are trying to control. So this is not so stable. So two motors, three motors, they are not very
I
stable.
think these are the just a micro category
Yeah,
or
small
the nano
small people
category.
are trying. Yeah, small categories. They have try. People are trying to do tricopter, bicopter kind of thing, but they are not so successful, or they are not so stable, I would say.
Okay.
But when you go for quadcopter, that is four, okay,
Yeah.
four motors, or hexacopter, six, or octacopter, eight. So in the even number segment, like I can put fifth also here, but that fifth will add complexity in calculating the
Yes.
calculating the
These are the
aerodynamics. Yeah,
basically these are following the geometrical principles.
correct.
And
So
since
what?
we have to move in the three-dimension directions, at least 4, 6, 8,
Yeah,
we
so
can go to even 12
even
or
number
16.
copters are more stable and easier to fly and all that. So most stable is the quadcopter or hexacopter, because
Hexacopters.
okay, here actually what happens, four motors means based on the four motors thrust, you will get the lift capacity, where here we're adding two more motors, So 6 motors means that thrust capacity will increase. So
Yeah.
you can carry higher payload when you have a hexacopter.
Yeah.
Whereas quadcopter will be more or less like a smaller cameras, surveillance kind of thing, and so. So you see DJI drones are more or less, they are always quadcopter because they are small in size. Okay.
Yeah.
Whereas agriculture drones you will normally see they are always in formation, because tank of 10 liters they have to weigh it up, lift up. Okay, so quadcopter are the most popular or widely used variant. Okay, so what are the pros of multi-rotor drones? They can vertically take off and landing. This is the first
Landings.
important. Then it has hovering capability, and the operation can be performed in a confined spaces. Okay, your fixed wing cannot fly in a confined space. It needs a big area to fly. Whereas wherever you have a challenge, like you are doing some industrial surveillance or operations or monitoring or those things, or maybe within like towers, your power line towers or your telecom towers or your windmills, or inside the windmill also, inside the blade, inside that tower of the windmills, or even chimneys, where you have a confined space operations,
Got
there
it.
you can use multi-rotor drones. But what is the limitations of multi-rotor drones? Limited endurance compared to fixed wing, less chance of recovery in case of motor failure. Like your motor failed, your drone will drop. There is no chance. There is only one drone in out of 101 type certified drones of DGCI. There is only one drone which has a recovery mechanism as a parachute. But even that mechanism, people are not using or not buying drones with that mechanism. So you can buy that particular drone with mechanism for recovery also.
Okay.
Okay, then as I said, limited endurance, because of the most of the time you will have a electric motor and all things, so it will have a limited speed compared to fixed wing or thing. Cannot perform high altitude long endurance Hale operations. That means it cannot go up very up. It will be limited, like mostly multicopter in India, whatever urban design will be always limited to 400 feet, not more than that. It will not fly above 400 feet or something like that. So single rotor drones, which is normally called as helicopters. So lift is produced using single rotor, high efficiency and maneuverability, high endurance by using gas powered engines. Ideal for large scale surveys or agriculture projects. As I said, Gujarat government did. So they have flown a fixed wing, not the helicopter, but earlier even helicopters were used for large scale surveys or agriculture projects. Downside is their complexity, operability, cost, vibration, and also danger of large spinning blades. So they will have, a helicopter will normally have a large spinning blades, which can cause lot of challenges because it needs that area to be available when it is flying on the helipad, and all that things would be required for helicopter. A single rotor drone being utilized for crop spraying. Like if you have a big farm, 100 acres of farm, and there you want to do a spraying and all things, so you can always use a single rotor drones. But again, flying this single rotor drone, you will have a challenges with respect to the complexity, operability, cost, vibration, and danger of large spinning blades. Okay, and then the infrastructure would be required for landing and takeoff these type of helicopter. Okay, whereas you will always have a hybrid VTOL, which is a combination of a fixed wing and multi-rotor. So takeoff can always happen like a rotor. So your drone will go fly like a rotorcraft. It will take off. Then it will transition from multi-rotor to fixed wing. Okay, that means it will start operation, it will transition, and then it will start operating as a fixed wing. And once it completes its operation, again it will transition back to fixed wing configuration to multi-rotor, and then it will perform the landing using multi-rotor. So advantage of hybrid is long range, high endurance, also hovering capability operations from a confined space. Like if you have an area like terrain, like like Assam and other places, you can use VTOLs to capture, because again every time you need to change your altitude based on the terrain type. So you can't fly fixed wing on this kind of terrain location continuously, because then you are suppose you may get uh, into the terrain spaces, and you may crash into the terrain and all that things. So fixed wing There you can always switch, or you can transition from multi-rotor to fixed wing and fixed wing to multi-rotor as on when you required, and you perform your motions accordingly. Okay, so there is a separate licensing certification for hybrid drones also of this type also.
Okay.
So there are some I think one or two institutes or RPTOs which are actually providing training and doing the practicals for
I
this.
think there is a company called AVPL International in Gurgaon or something.
Yeah, AVPL is there, or Iruga is there, drone destination is there, or there is one more company in Chennai also, CSR or something, CSIR something is there. So they are actually providing hybrid VTOL trainings. But
Okay.
this will be very helpful when you complete your basic training. Like you now you do small, then probably you upgrade to either to medium, or you can upgrade to hybrid also, depending upon your requirement.
Got
ऐसा
it.
हो सकता है कि you take, I mean I have seen people who have done these trainings, but they are not associated with any of this kind of activity. So there is
Got
no
it.
point doing that kind of training. See, if you are doing a training, then you should be occupied into this kind of flying this type of devices, then it is useful, or else
Okay.
just by sake of doing training is not going
What
to
I
be.
understand is these are like more complex kind of a drones. So why to jump onto that without any experience or without any?
Correct, because here you are doing, even doing transition, like when you're in the motion, in the in the flight itself, you are changing from the what we call as multi-rotor mode to fixed wing, or fixed wing to multi-rotor kind of thing. So that's a little bit crucial. And but still, I can say it is stable, okay, more stable, because nothing would happen. Even like, let's say you stop the fifth motor, what will happen? It will glide because of the wing, and that point in time you can always start your multi rotors, and vice versa. Okay, so it's only need practice, it's only needs, like your visibility to fly these type of devices. Okay, so this just a small, since we are learning about the unmanned aircraft system, uh, we are talking about the history. So it started in 1849. So first UAV was actually 1849, that is Austrian balloons measuring 5.7 meters in diameter. Austrians attacked the Italian city of Venice with unmanned balloons loaded with explosives. So actually they built hot air balloons, okay, and there was a payload attached to it, a basket kind of thing, which attached with lot of explosives. So they calculated like this. I fill this balloon with the hot air, or hydrogen or whatever. So it will fly in a particular direction. It will go, and like they will calculate like how much time does it takes to cover the distance. So based on that, they did calculation, and your drone, sorry, not drone, the balloon will fly from this location and it will reach this location. And once it reaches this location, let's say 1 hour approximately, I'm just giving an example, or maybe 2 hours, okay, whatever it is. So whatever duration it will get, after 2 hours, they assume that the drone would, or the balloon would reach a particular destination or location, and then from there onwards, after 2 hours or 2 hours 10 minutes, it will just simply start detaching its drone on its own remotely. Okay, so they have created some fuse mechanism so that it is automatically able to discharge the drone and drop the drones on this location. But fortunately, I would say nobody was injured that point in time. So this was also done by Japanese during the World War II, where they have dropped these type of drones, or I would say using balloons to drop the explosives. So this was the first use of UAV under unmanned aerial vehicle kind of thing, in form of a balloon.
Okay.
Okay, but as I told you, the evolution of the drone, like it started from 1849, 48 that time. Then Nikola Tesla in 1860 demonstrated that by using radio waves you can control the boat, and that's how this remote mechanism of controlling the drone comes into the picture. And by 1940s, we were into the World War II. That time, lot of aircraft which can be flown remotely were used to, like a targeted military destroy the target kind of aircraft they have made, and it got land and destroyed relatively the enemy sites and all that things.
Okay.
So then post-war, most of the time it was used for different type of research and all those things. Whereas in 1986, in Israel and American military started using the Pioneer drone which was developed, and subsequently it was used in Afghanistan in Desert Storm also, or monitoring of climate. Then some peaceful activities were also performed at that point. But at the same time in 1900 series, during the Iraq war and all thing, so Predator were used for surveillance or either for Hellfire missile, launch the Hellfire missiles and all the things. However, actual drone was adopted by the civil. So if you see till 2000, the drone was more or less was under the military. I mean, no normal people or civilian people were thinking on
So
that line.
basically, this whole
100 years.
innovation and this technology foundation was the military requirement,
Correct, correct. So
and
drone was predominantly was initially thought from a add-on to the military
military
power.
usage.
Yeah, military usage. From 2000 onwards, people started thinking that whether these drones can be used for some day-to-day work. So the people had drones with small cameras built in and all that things. So initially started for like videography, photography kind of requirements, and then by 2010 it started taking up. Okay, still it was not so much used. Like if you see in 2014, we had a company called Idea Forge. Okay, if you have seen a movie, Three Idiots, in that movie there was a
Yeah.
drone which was shown flown and other things. So that was a drone made by three students from IIT Mumbai. Okay,
Okay.
which further in 2014 they went on to form a company called Idea Forge. Okay, so today Idea Forge is the I would say number one company in manufacturing the drones and selling it to the customer. They have their own IPO and all that things also.
Okay.
So Idea Forge basically sells most of their drones to defense and lot of government projects. They are also working closely with some American companies and other things, where they have set up office in America also to sell their software. So they are building their own drones, and as well they have built. I mean, they are trying to build the complete ecosystem. So not
Okay.
only about building the drone, but they have also been successfully able to have a software which can take care of flying the drones as per the requirement. Okay, so they have
Okay.
their own software, they have their own hardware. So they're trying to build the complete ecosystem for themselves. Okay, then came I mean, US government adopted the drone segment and drone rules they have set up and all the things. Parallelly, same time 2015, the DJI also came into the picture, and DJI started focusing more on the drones and all those things. And then you saw this phantom drones or mavic drones comes into the picture around same time, 2016 2014. And if you see by the time 2017, lot of issues were there raised by different people across the globe. So legality, ethics, and all these things were coming into the picture, and every company or every country was trying to adopt and understand how the challenges what are there or teething problems were there in the flying of the drones could be addressed by Ayuka. So, as we talked about the history of the drone, so father of the drone is Dr. Abraham Karaim. He was born in Baghdad in Iraq, later moved to Israel in 1951. He was aeronautical engineer from Technion in the Israeli Institute of Technology. Built his first drone during the Yom Kippur War or for the Israeli airbase. So he built the first drone for that particular. In 1970, he immigrated to United States. That means he left Israel and he moved to United States, where he founded the leading system. in corruption and started manufacturing his first enterprise drone, Albatross. Okay, so he manufactured the first drone, and later on, this drone was actually acquired by what we call US Defense, and now this drone is called as Predator drone, which even Indian government has purchased it from US. So, inventor of a modern day combat drone, Predator, which was bought him the title Father of the Drone.
Father of drones.
Okay, so if somebody asks you who is the father of the drones, it is
Abraham Karim.
Ram Karim. Okay, so what is the future of the drone? Like future of the drone with lot of cutting edge design, engineering, still technology advancement are going to be a key differentiator for drones in the future. Like you can see a drone taxi.
Yeah.
At today morning also I have seen one good video of drone taxi in the LinkedIn where there was a single person sitting in the drone with four propellers on the side. It was more or less like a bike. It was more or less looking like a bike only. Okay,
Okay.
you can fly like how you enjoyed the bike riding. Similarly, tomorrow you will be sitting in your own drone and flying across the city or various places and everything. I mean, it will completely change the world of transportations once that becomes more and more reality and all the things. Whereas drones is extensively adopted into the agriculture segment, so we never know what could bring a revolution in agriculture, like spraying, seeding, or probably monitoring also and all things. Okay, there is a concept of a drone where people are talking about what we say no wings or no propellers or propellerless drones. Okay, so these are just a concept people are trying to build anything, and then they're trying to see whether they have enough thrust can be created so they can be commercially useful or viable solution kind of thing.
Got it.
Of course, the drones are taking up very much now into the supply, and I see that this is one of the game changer or will be the one of the biggest adoption because this is going to set up the entire drone ecosystem. Okay, up till now we are just flying the drones for a smaller area and small locality kind of things and all things. But
Got
when
it.
we start flying drones for supplying and all the thing, you will have a bigger setup, not only from a physical drone and all the things, but even from the infrastructure side, software side. Lot of reiterations or lot of changes has to come up, and lot of ecosystem is required to be
Mm-hmm.
built. Okay, whereas there are some smaller miniature drones which looks like a very tiny toys or tiny, bee-shaped or kind of things are which are basically used for spying or kind of those kind of activities, which will capture your images or motions and all that without you actually knowing what is happening around you. So Tesla also has come up with one of the design where it has introduced two popular drones, and they can shift or position themselves either horizontally or vertically motions, and then accordingly it can fly
Yeah.
autonomously and give the
I have read an article on this.
the shape shifting ability of the
Yeah.
drone, also wonders of image stabilization. I mean, it can have a very stable images and all that things. So let's see what is the anatomy of the drone. So if you see with respect to the drone, a quadcopter drone, you will have a propeller, you will have a motor, and then you will have a frame, okay, on which the motor is fixed, okay, with the propeller. Then if you see, it will have in attached to the frame or the legs or the arms, what we call, on which the motor is attached. Below these arms, you will see a electronic circuit board, a small circuit board, which is also called as electronic speed controller. Okay, so this is the speed controller where the data is fed from the microcontroller to the ESC. The moment I give the signal from the drone, it will try to interpret and understand what is supposed to be done. Accordingly, it will send the signal to the motor via ESC, and ESC will generate the required motions in the drone. Okay, then you have a camera on top, that is a FPV camera or a first person video camera. Then you have a flight controller, which is a brain of the computer, sorry, brain of the drone.
Drone.
And then you have a receiver from where you can receive the signals from the transmitter and vice versa. Then you most important part is the landing gear, which actually supports drone when it lands on the ground, as well as when it has to be stopped operation for a particular location. Okay, then below the frame of the drone, you will have a battery pack, which will be actually called as a powerhouse of the drone, which will be providing power to the drone for making sure that your drone is flying as per your requirement.
Got it.
Then, yeah, then you have something in front to capture your images or videos, a camera with a gimbal. So these are the some basic
That
components.
camera with camera gimbal is usually that detachable payload, right?
Yeah, yeah. So the you can unscrew the gimbal also, as well as you can remove the camera also. I mean, camera can be anything. It could be a DSLR camera, it could be a GoPro camera, or it could be a very specialized high resolution cameras also. I mean, it can be
Okay,
connected with
okay.
gimbal anything.
Understood, understood.
Okay, so if you see from the anatomy perspective, propeller is, as we said, propeller is which converts the rotational motion to the thrust. So as it moves, it will generate the airflow and which will push the air downwards. And since it cannot push the earth, the drone will rise up in the air. So there could be a pusher or the puller motors. The pusher is clockwise, whereas puller is a
Anti-clockwise,
clockwise,
yes.
okay, or counterclockwise we call it as. Whereas the propeller dynamics can be modeled by Bernoulli principles and Newton's third law. So as it is pushing the air downwards, it is following the Newton's third law.
Yeah,
Whereas
and Bernoulli is fixed wing.
the wings, actually the propeller design, what is been is following the Bernoulli principle. So
Okay,
you have a leading edge as well as you have the trailing edge here. Okay.
okay.
So if you see these propellers, these are the two different types of propellers. Can you make out?
The both the angles of those wings are in the opposite direction.
Correct. So if
That
you
is,
see
one is in the clockwise and one is in the anti-clockwise direction.
anti-clockwise, so looking at the propeller, you can find out based on the Bernoulli principle, which is the leading edge and which is the trailing edge, and based on those leading edge, trailing edge motions, you will able to understand whether it is a clockwise or whether it is a counterclockwise
Anti-clockwise.
propellers. Okay. So to move this propellers, we need motors. So motors are used to rotate the propeller. So we will always use BLDC motors or brushless DC motors, highly efficient and long lasting. The key parameters to focus here is motor speed, thrust value, compatible ESC and compatible battery. So whenever these motors are being made, they will have a standard propeller which will be specific to this particular model. So every motor will have its own set of propellers and it will have a compatible ESC. Okay, so you can't use any combination. You have to use, if you're using this. I mean, it depends upon how the drones you are getting designed, how big the drone you are getting designed, what purpose you are designing the drone. So based on that, you will choose the propeller as well as motor and the ESC. Okay, then you have electronic speed controller. So as I said, motor will come with the compatible ESC. So electronic speed controller is used to vary the motor speed with precision. So when I give the power to the motor or raw power, it will move the motor in a fixed rotation, okay, fixed RPM, whatever power it gets. So I want to vary, so my electronic speed controller is nothing but it's like a regulator. Okay, so which can control the direction of the rotation of the motor, CW or CCW. I can interchange the wire and I can change the direction of the motion of the motor, but this can be done in a smaller motors. But if you have a big drones, so there where you have a motor configured or designed or built only for a specific motion or direction of the motion, so motor can be a CW or can be CCW also. So if you have a motor with CW, you have to use it as a CW only. By interchanging, you can change the direction and make it CCW, but that is not advisable in a bigger motors. Okay,
Okay.
and as well as your what we call the ACs are also used to act as a dynamic brake. So that means it can stop the motion of the motor or the propellers moving, and also it pops out. I mean, it eliminates battery eliminating circuit for powering the flight controllers and receivers. So it will have a segment where it can power off the flight controllers or the receivers from the AC itself. Okay, so it will be a very controlled green
Okay.
power kind of thing, because battery again
Okay.
is the raw power. Okay,
समझ गया.
managed and all things. So you need to power this critical equipments, like motors will be very expensive. Your flight controller like Pixhawk would be very complex and very costly, because this is the main component of the drone, and this is the most expensive in the drone. Okay, so this needs to be protected from high power or high current voltage and all the things. So in that scenario, your ESC or the power distribution board comes into the picture. So we see flight controller or autopilot. It's the brain of the US, helps in flight stabilization, navigation, and fail-safe redundancy. Most common flight controllers are developed by Ardu Pilot or DJI, like 3N3, NASA, M-Lite, NASA MV2 or A3, etc. Or mostly used is the Pixhawk. Okay, Ardu Pilot Pixhawk is the mostly. I would say that 95% of the drones worldwide use Pixhawk or its variant.
Okay.
So there are a lot of variants are also available of Pixhawk, but again they are derived from Pixhawk only. Okay, so that's how it is. So Pixhawk is supposed to be the most stable flight controller across the world people use. So based on this concept, again Pixhawk was developed by Ardu Pilot. Ardu Pilot is again free. Okay, so you get this component purchase, like this Pixhawk may cost you around 12,000, 15,000, but higher stable and good quality Pixhawk variant may cost you double the price. It may cost you 30,000, 38,000, 40,000, like that. Okay, so
Okay.
more complex, more features and more settings and more connectivity, whatever is required, will be more expensive flight control. Okay, now if you see, now to house these motors, flight controllers, propellers, all the things, you need a frame. Okay, so UEA frame consists of housing the enclosing electronics, motors, boom arms, and platforms. There are different configuration of the quadcopter. It could be H shape, X shape, plus shape, or it could be H hybrid also. Okay, so depending upon different requirement and different configuration, you can design how you want the shape of the drone. Okay, core configuration. It only adds plus here and there the efficiency, and some people want to make it different look and all that things. People will make, but more or less, you say there are four motors in four corners, as simple as that. Okay, nothing is changing over here. It's how only you can connect, you can design the way you want the frame or the the things how you want. It's all up to you, because anyway these are not aerodynamics. Okay, there is no aerodynamics into this. You can bring aerodynamics, like if you see the phantom drone. Okay, though it is a x shaped configuration kind of a drone, but see the body, the linearity or smoothness what they have built into the.
Basically, sir, we have to maintain that center of gravity.
Correct,
Uh,
correct. And the
what's it
overall
called?
aerodynamics. If you see the Phantom drone, it is very aerodynamically and simple design what they have made it. Okay, or even you see any DJI drones, there they have some aerodynamics built into it, or maybe modularity. Okay, you see how the drones, the propellers, all they, once you are not doing any operation, you can close that, put it in a small case, and just carry it anywhere. Okay, so even that helps, then how you design the airframe. Now, to once you have a frame and all the components, you need a power to power your drone, right? So you need a battery pack, so which is nothing but power plant of the UAV. So either you can use lipo or lithium ion, which are widely used. So high energy density compared to the conventional batteries, and it's vary by discharge rate, capacity, and voltage. So you can see at what C rating. Okay, the higher the C rating, it will be the higher discharge rate. Then capacity is like 5,000 mAh, 10,000 mAh, 16,000 mAh, 21,000, 22, 30,000 mAh, 42,000 mAh. Depends upon the number of cells and all the things it will have. So here you can see it is written 2S 7.4 volts. Okay, so
Hmm.
you will have a two cells into it. Whenever this 2S, it could be 2S, 3S, 4S, 5S, 6S. Okay, you we have seen batteries up to 6S cells. So it depends upon number of cells what is been put into the battery. Based on that, the voltage would be on a higher count.
Got it.
Okay. Then your quadcopter anatomy, you can always have a camera with the gimbal. So gimbal is basically used to mount the payload, as well as it helps in stabilization, because when, see, if you do not have a gimbal and you directly connect the drone, you directly connect the camera to the drone, what will happen? If I want to take the shot in an angle, I have to manage my drone accordingly.
Okay.
Whereas if I have a gimbal, I do not have a dependency on the drone. My drone will be flying at a very stable, constant, smooth operation flying it will be. But still, since it's a vibrating kind of thing, the drones are, or motors are moving, so there would be a minimum, some vibration would be there. Okay,
Understood.
vibration would be there. So
So
it will
then
be
it
stable.
will affect the output of imagery or whatever we are
Correct,
going to
correct. So you
get
will
out.
you will see lot sometimes blurry or zigzag into your shots what you are capturing and everything. So to reduce that, you will have a gimbal. So first is not depending on the camera motions, or motions of the drone or position of the drone. Drone will be at a very stable flight. It will be in hovering condition, and you using the gimbal, you can change the angle of the camera to capture the particular location. You can capture it at a 0 degree to 90 degree facing the ground itself. You can
Got it.
capture in any direction, and you can take a 360 degree shot also, like by using pan and tilt motions. Okay, like you can pan completely 360 degree to get the complete 360 view of the area or whatever it is. Now all these things along with the frame and everything you need, since your drone flying, it needs to land. So when it needs to land, it needs to have a stable landing structures or struts. Okay, so these are the legs that drone rest on when it is landing or grounded. Comes in a different shapes and size as per the design of UAV. Okay, can be folded with the help of a servo mechanism, resulting in better field of view, like desire DJI Inspire. You will see this landing gear, when it is in flight, it goes up so that it is not obstructing the view of the camera, and then camera can take complete 360 degree view of the location without moving the drone. So drone will be at constant, and using the gimbal you can only move the camera in 360 degree. That's the pan
Got
motion
it.
you can do
Got
it.
it.
Okay, so a lot of time it was seen that the what do you say, the legs in between in the images or in the videos, you will able to see the legs also. So that has been removed by putting a servo motor to the mechanism, so that the landing gears goes up, or how you see in aeroplane also, the wheel goes inside the belly of the aircraft. Similarly here, the landing gear goes upside, and then you can have a clearer view. So only during the landing position, the landing gear will come down and it will land on the landing gears.
Got it.
Okay. So now after seeing all the components and important components of thing, we need another topic about the radio transmitter and receiver. So as we said earlier, radio controllers transmit the input given by the pilot to the receiver via 2.4 gigahertz. That's why we had that spectrum, right, where we talked about which range the controller is going to talk and all those things. So it is
Yeah.
2.4 gigahertz.
Ultra high
Yeah,
frequencies.
yeah, ultra high frequency. So communication link preferred frequency in these devices is 2.4 gigahertz because of the maximum efficiency.
Yeah.
Whereas the video transmitter of your FPV camera is done at the 5.8 gigahertz, as it provides the noise free and the best quality video signal.
Video
So
signals.
at that frequency, it is providing a very good. I mean, you don't get buffering or anything or any noise and all things. So at this frequency, your video transmission is happening, whereas communication link is happening between 2.5, 2.4 gigahertz.
Got it.
Additionally, you can always have a telemetry connectors also, like you can air end it connected with the UE, so that you can have a separate ground control also, which can, like I told you, right, you don't require this flight controller, but you are flying a drone using a ground
Laptop.
station, okay, laptop or a ground station kind
Yeah.
of thing. So ground station will have a transmitter like device, and then the drone will have a receiver kind of device, which will communicate to, they are binded to each other and they are communicating to each other, and then from here you can upload your mission into the drone, and then drone can perform all the maneuvers, all the location, and simultaneously it will be providing crucial telemetry data like altitude, distance, speed, wind speed, etc., etc., temperature, and all sort of things are telemetry are being provided. So dynamic updation of the flight plan and any change in the mission can happen through this telemetry devices, through the ground control system. So even if I want to change my flight plan, I can always pause my drone motions. I can correct my flight plan and resume on the new flight plan and all.
Understood. So it's like real time changes
Correct,
executable.
correct. So here you can just like you may have defined a flight plan where you have decided that you want to fly at 2000 feet. Later on, you understood that there is a challenge in flying it. I may want to increase the height, so you can always pause it. So it will be in hover position. I will modify my plan and I will say resume. So it will resume from there the further motion or mission kind of thing.
Yeah.
Okay, now these are also like this we talked about this. These are some safety points or from a from the understanding point of view. Like we like if you're flying a drone under BVLS or under night condition, we will not able to see the drone. So if we don't have a strobe lights or the lights on the drones, we will it will be very difficult to fly the drone in night. Or if you're flying a very far off drone, then I need to have a device called ADSB, which is automatic dependent surveillance broadcast. So this is actually a small unit which actually broadcast its position via satellite navigation and periodically broadcast it, enable it to be tracked. This is
Okay.
the key to the airspace safety. When we are flying a drone in the airspace or manned aircraft, okay, that time it will become a mandatory. So as of now, we are limited with 400 feet of flying the drones. That's why this is not mandatory. But the moment you reach a BVLS condition and you are flying in a manned airspace, this will
Yeah,
be
then it becomes a security and safety issues.
correct. So then this will become a mandatory for it.
Yeah.
And as well as in night flying, you need lights, like how you have a lights on the aircraft. Similarly, you need to have a lights on the drone also. So based on
Understood.
normally people put red lights at the back side of the drones, and front side
Got
they
it. Got it.
maybe a white light or kind of things would be there, so that you identify the orientation or heading of the drone. Okay, then the inner electronics, now not only the flight controller. Okay, we seen here the flight controller, which is the brain, but then flight controller along with different devices, it will function because it needs a lot of inputs. So the microcontroller is the brain of the flight controller. This collects the measurement from all the sensors. It tells the motor what to do based on both sensors and user inputs. Okay, it could be a input from the sensor or could be user, like I'm giving pitch forward, pitch back, or I'm doing yaw or roll motions and all these things. Based on that, the microcontroller will give the signals to the motor, and then motor will actually performs accordingly through AC.
Got
Okay,
it.
so apart from microcontroller, there are other circuitries are also there, or small circuitries or small components are there, like altitude and heading reference system. So this actually tells which side the drone is, the front side or the back side, and based on that it will know when I'm saying what is the direction of pitch forward, what is the pitch back, what is roll right, what is roll left, or yaw motions and all the things. So we'll be knowing from this particular circuitry, which is called as
Understood.
altitude or heading reference system. Then there is something called IMU. Okay, IMU is another electronic device that measures or reports a body specific force, angular rate, and magnetic field surrounding the body, or it may have something called as a magnetometers. So it will incorporates accelerometer, gyroscope, compass, and magnetometers. And these are important components, or this is an important device which gives the complete orientation of the drone with respect to the position, altitude, the speed at what it is moving. The compass means the heading or the direction of the drone, and the magnetometer, so that it can tell about the magnetic field surrounding the body. So it also allows GPS receiver to work when GPS signals are unavailable. That means in case of GPS failure, IMU can also help drone to fly or maybe to land the drone safely. Okay, then for an accurate position of the drone, you may have a separate device or separate sensor called GPS system. Okay, so GPS module is responsible for provision of longitude, latitude, and elevation point. Okay, so it will give you three inputs. It helps drone navigate in BBOS and capture details of the specific location on the land. So basically, the GPS will come into the right now. All the drones are equipped with the GPS and everything. but it will come. I mean, we are flying using GPS and all that things, but it will become very, very important when we are actually flying under BVLS condition. So GPS helps in enabling the device return to home, so that whenever you are from a particular location, you are triggering the drone to take off. That position from where it is triggered as a takeoff, that position is called RTH, or return to home, or return to launch position. So in case of any kind of failures, like it could be a GPS failure, battery failure, or battery degradation and all the things, in that scenario, you want your drone to be come immediately back and land at the safe location of from where it is flown. So that is called as RTH, return to home. Then you have power modules where input is connected to the battery, output is connected to power distribution board. It provides 5 to 6.5 volts to the flight controller. It also acts as a voltage regulator, which converts the input into specific amount. So if you see here, there is a connector connecting to the battery side, whereas there is a connector which connects to ESC or PDB. Okay, that is power distribution board. So you will have a board which will connect a board here. Okay, and then it will distribute to the four ESCs or four motors. Okay, and then on this connector itself, on the power module connector, or the connector, there will be a small circuitry which will actually monitor the performance of the battery, or the voltage coming from the battery, and give inputs to the flight controller, and then it will display on your GCS or on your remote controller about the status of the voltage or the current, and that will give you the health of your battery also. Like when we are flying the drone, we have to continuously monitor the battery usage also. Like we have 100% battery, we will fly the drone only up to 50%, or max maybe 40% also. Beyond
Okay.
that, we'll always safely land the drone, and we'll replace things with the battery, because there would be a threshold would be set at somewhere around 30% or 35% kind of thing. So there are various thresholds are been set based on your requirement and where you are actually flying and how your battery performance is happening. So there are people who are set up the threshold also. Again, it depends upon how far you are flying, because if you are set up threshold and you are set up that you can fly up to 20%, but whatever after 20% it is left, and it triggers the RTH, but within that 20%, maybe the drone may not be able to reach to RTH position. So you need to know how much percentage of threshold you need to set. Accordingly, you need to set the threshold. So safe fit is normally people follow is 50% is utilization of the drone. After 50%, you remove the battery and change the battery. That's how you improve the life cycle of the battery also, or charging cycle of the battery also.
Okay.
Okay, so that was all about the inner anatomy of the drone and the different components of your rotorcraft. Now let's see a couple of what we say. Uh, what are the applications of drones in various sectors? We have been talking about drones used in agriculture, you've been used in forest and wildlife, urban development, healthcare, traffic management, homeland security, disaster management, or even mining. So we have seen applications across this type of sectors,
Yes.
depending upon the type of drone you build or you design or you purchase. You can use them for different applications of the drone in various sectors. Okay, these are some of the business ideas for UAE industries. Like you can use it for aerial photography and videography. You can use it for commercial inspection services. You can use it for survey and mapping services. You can use in logistics. So different things are being used. So Australia Post, Amazon has already started drone deliveries, medical supplies, organ transportations, relief operations. Or if you see commercial inspection services like bridges, cells, TV towers, power lines, even aircraft, railways, wind turbines. Like I have seen a drone which was built to monitor or see the health of the the high speed railways,
Okay.
internals of the railways or internal structure of the railway, when they have completed their transportation and all the things. So when it is practically impossible to monitor the structure by a human. Okay, So there are possibilities, since we are involving the railways, or like the high speed railways which are moving. So practically monitoring by a person is always a challenge, because the same routine work over the period, initially you may do it religiously, but over the period of time you might take it granted, and that's where actually the accident or incident would happen.
Understood, understood.
So it's always, we rely somewhere on the automation part, or drones going under the railways, or maybe around the aircraft to monitor and scan, complete, and provide the report and all the things. Similarly, again, wind turbines, mines, oils and gas pipelines, sonar panels, blah blah. So many things you can go for commercial inspection service, also for survey and mapping services. So it basically provides companies with 3D digital elevation, fencing data, survey construction sites for urban planning and development. Okay. Some more business ideas like residential home inspections, like check roofs, chimneys, slidings, bricks, and other structures, external damage inspection. High towers also can be monitored using UAV. Then, as we see, a lot of adoptions are happening between the drones and all things. In India, you will not see much of the DJI repair shops or DJI repairs, and all those things are happening. But this is also one of the future where technicians would be required, as have more and more drones available.
Yeah,
So open a shop of a maintenance or repair of drones, spare parts, procurement, and mapping, and all that things. Again, this new segment has come where the drone aerobatic shows, events like drone racing, or organize your own
even
competition.
sir, I came across a company. Actually, it is just in that inception form, but they are planning to operate their coordinated swarm shows.
Right, right. So that's the digital display of the drone.
Yeah, exactly. In UP or somewhere, they even executed those.
Yeah, lot of like, even on during the Diwali or New Year,
Yeah,
or
actually for that.
even people are now utilizing these drone shows in wedding also. Okay, a lot of people are using it in wedding and all. So hardly you need 500 drones, something like. The more the drones you have, more like every drone is like one pixel. Okay, so the more drones you fly, you coordinate, you can program and everything, and then you can get a good images in the sky, and so which will be visible from a very long space, and a lot of people at the same time can see all these things simultaneously.
Yeah,
Okay, so again, some more like data analytics, analyzing, processing various forms of data, projecting trends and patterns used in present data. So based on the data what you captured using the drones, you can perform the analytics and provide the reports, or project the trends and patterns to the customers or the client. Again, engineering consultancy like drone identification, procurement, operation solutions, obtaining UI and UAP, and being a DGCA compliant. I mean, this probably future, engineering consultancy would be requiring all these things to be done, or maybe the software based
solutions.
people can be related to flight planning, controller, and diverse data processing, analytics, app development, and all the things. We never know. I want to deliver continuously, like every time the drone would come onto my shelf. I know, probably like how you, if you go to McDonald's, one is you can sit and eat over there, and one is called driveway. So you remotely, you can, over the mobile only, you can put the order, and you say you are going to drive. And
Understood, understood, sir.
so similarly, future, not a driveway, but there could be a there in front of your balcony, or some place in your flat. You might have a place where it can down. I mean, it can what do you say, land the drone and drop the package. Okay,
Packet parcel.
so you can make mechanism such a way, or software, where automatically the drone may go to the McDonald place. It will take up your basically your parcel. From there, it will fly and come to your position and drop it to your location also. And it will trigger maybe a update on your mobile and tell you, okay, your parcel has been delivered at your landing zone, or all things. And then we talked about UA insurance. So insurance company had also geared up, and they are like, there are other industries are also which are getting business from the drone adoption. So the more and more adoption happens in our day-to-day life, Like if you see, initially it started with just a useful for a military, then it took for the aerial photography, then you started with agriculture and infrastructure, and then whatnot. I mean, it is almost trying to adopt the drones for different segment in the society. So if you see this last picture, which is we call as the connecting society or internet of drones in the future, it could be in agriculture surveillance or agriculture spraying, seeding kind of, or medical supply delivery, smart grids, monitoring your windmills, or maybe towers, power line towers and all the things, or drone ports, okay, where you can land your drone from one location to another location, change the battery and all that things, or servicing can happen, traffic surveillance can happen, factory monitoring or factory intralogistics things happen. Within the factory, you want to move the material from one place to another place. Like a lot of Amazon stores, you would have seen, a lot of time the material comes into the Amazon stores. They have been segregated by using flying drones or the robots over there. Okay, or on duty drones for first responders also, in case of any emergency or any issue. The drones can support a medical help or support to them. Again, you can use it for your private or hobby purposes. Climate monitoring it could be used, even for traffic or railway monitoring, traffic surveillance, real time notifications. And in case of there is any accident or thing, it can always respond or provide inputs on that or this thing. So we'll see in future, like there would be a lot of driverless cars, or probably a driverless buses also will be available. So all this will help to adopt more and more drones into our day-to-day life. And nevertheless, in next 5-10 years, we will have our city line or skyline with more and more drones flying across, right? So with that, we complete the topic of the rotorcraft operations and aerodynamics. So I think we are already now 6. So by mistake, by clicking on the PPT,
Yeah, I got it. I got it. मुझे
I
लगा ही
closed.
ऐसे कि आप शायद से गलती से निकल गए.
Uh, so sometimes you don't know, you see that cross similar, so that's why that's happened. Okay, so with this, we more or less complete today's topic. Only small topic of hybrid operations and aerodynamics is left, which we can take up tomorrow morning. So if you have any questions to talk or ask, you can let me know, or we can complete our today's day over here.
I think we can complete it, sir, because whenever I felt to ask any question in the real time, I asked you the questions.
Right,
अभी ऐसा जैसे मेरे दिमाग में नहीं है कि मैंने ऐसे कुछ नोट डाउन करके आपको कुछ पूछूं, because most of the things are clear in my mind.
right. Absolutely, absolutely. Okay, so see you tomorrow at 10 a.m. I will be shortly sharing you the email with the summary sheet and we'll touch base tomorrow also about the drone rules document also. Okay, but anyway, I will be sharing it to you tonight. If impossible, you can go through them, or you can print it as you require, whatever way you are comfortable. Whether you are comfortable on soft copy or hard copy, depending on you can do it. But I would suggest you to take a printout of a summary sheet, at least summary sheet, so that you can read them, mark them, make a point over there in case you want to know more about it. Okay, just
Sure,
11
sure,
pages, right?
sure.
So see you tomorrow. Thank you, and I hope I have delivered today whatever the lectures I have taken or modules I have taken, and you find it very relevant and important, and I was able to give you,
Definitely, definitely, sir.
right. Okay, thank you, Rahul. Then see you tomorrow. Yeah.
Yes, sir. Yes. Thank you so
Okay.
much.
Okay. Bye.
Bye.